G'day again. Last video I sort of introduced what a 3D line looks like, what the equation of those look like. Talked about what the vector equation looked like, what the parametric equation looked like, and the Cartesian form of that line looked like. So today we'll sort of try to make that a little bit more solid and sort of go through a robust example. So let's have a look at this. So here's an example. Determine the equation of the line in Cartesian form passing through some original point P0, which is 2, -1, 3, parallel to V equals -I plus 2j plus 2k. So again, like I talked about, the our vector equation, which I will start with that, all right? So you never have to write vector equation, but I want you to get used to this language. The vector equation is going to be RT is equal to R naught plus TV. All right, so it's that. And so what we do here to create the vector equation is R naught is your starting point, okay? And so our starting point, so if you think about the position vector of this, is just your starting point. So let's write that down. The starting point there is 2i minus j plus 3k. Okay, so that's my R naught. That's my initial position where it's starting through. We're starting from that point and we're shooting off in this direction, this V vector. That's the direction of it that it's going to be shooting off. Okay, so we've got that. I'll just do this in two different colors. So that's red and that's blue. Okay, so then we're going to go plus T, and the second part of that is shooting off in this vector direction. So that's going to be -I plus 2j plus 2k. Okay, and so that essentially is my vector equation. We've added the initial point there, and it's shot off in a direction. The parameter of this is t, and it's shooting off in those. It's going off in that direction. Okay, we can simplify this though. So let's do that to make it put it all together in i's, j's, and k's. And so what do we have for i's? Let's have a look. I'll put the I out the front, and then we have 2 over from the left-hand side. From the right-hand side, we've got minus t. Okay, so that's the i's. What have we got for the j's? We've got -1 over there, and we've got plus 2t from there. So -1 plus 2t. And then for the k's, we have 3 plus 2t. And so that is my vector equation. So that tells you its position at any sort of time t. So you could substitute in there t is equal to 1, times equal to 2, times equal to 3, etc., etc. And that will define the line that goes out as that sort of position vector changes. And so that's our vector equation. All right, now how do we change that into parametric equation? Okay, so we've done this before, but now it's just sort of a sort of different sort of situation. So let's do parametric. Okay, so parametric is basically that's our x, that's our y, and that's our z. We've done this before. We know how to do this. And so here we go. All we do is we go, well, x is equal to 2 minus t. We've got y is equal to -1 plus 2t. And z is equal to 3 plus 2t. Okay, so there are parametric equations. It's as easy as that. And when you get good at these, you can read them straight off the actual question. You could come straight up here and here and read those directly from there. So you'll get good at doing these, and you'll see the links between those sort of different versions. Okay, but the question actually wants Cartesian form. Okay, so we don't want any t's in there. So we've got to remove the t's. And so what we need to do here is equate the t's. All right, so I'll show you what that looks like. And I'll do it as a new sort of section. I'll do it in green. So let's have a look at Cartesian. So remember, when we're doing Cartesian, we're trying to get rid of the t's. So I'm just going to rearrange for t in each of these different x's. So for that first one, instead of x equals 2 minus t, so I'm just going to rewrite that here. How would I write that? T is equal to 2 minus x. Okay, so I've got that t there. How would I rewrite? Should I get rid of that? I just don't want that arrow sitting there. Sorry. But that's essentially what I'm doing. So t is equal to 2 minus x. I rearrange that. And then similarly for the y, I've got t is equal to, and I'll rearrange that. So add 1 to the left. So y plus 1 over 2. So y plus 1 over 2. So that's, if I rearrange the y, I'll get that. And if I rearrange the z, I get time is equal to, it's going to be z minus 3 over 2. Z minus 3 over 2. And so there you have it. I've got 3 equations and they're all equal to t. And so what I now do to get rid of that, I just set all those equal to each other. And so this all gets put into the same equation. So it'll be 2 minus x is equal to y plus 1 over 2, which is equal to z minus 3 over 2. And that is the Cartesian equation of this line. It gives you for what values of x, y, and z satisfy this equation. Will give you all the points that go along that line. And so that's how we find it. So let's just go back to summarize that, because you'll be doing this a lot. How do you find the equation of a line that has a point and a direction? Firstly, write it out as a vector equation. Starting point plus t times the direction, which is what we did first. Then pull out the parametric values. So x equals, y equals, z equals, just pull them straight out of your vector equation. And then the Cartesian equation, you just rearrange it for t, and then equate all the t's together, and you'll end up with your Cartesian equation. So hopefully that clears up a little bit of the stuff from the last video about how to do that. Let's have a look at one more example for this video. Let's have a look at this question here. So for this one, determine the Cartesian equation of the line passing through that point and that point. So point P and so point Q. And so you're not given a direction here. Okay, so you're not given a direction. You're given 2 starting points. Potentially you could start at either P or Q, it doesn't matter. But we need to figure out the direction. And if you think about this, if you've got point P and you've got point Q, then we know that the direction will be the line PQ. All right, so PQ will actually give us our direction. And so that's what we're actually going to use here. Okay, so let's do that. Probably should have deleted that, but that's all right. So our direction vector V is going to be equal to PQ. Okay, so vector PQ. What is vector PQ? Remember, that's OQ minus OP, which is equal to 1 minus 3i, so that's negative 2i, and then negative 2 minus 0j, so that's negative 2j, and then 2 minus negative 1, so that'll be plus 3k. Okay, so vector PQ from point P to point Q is that vector there. And so that essentially gives us the direction of where it's shooting out. And then we could use anything as our P. And so I'm just going to use, I'll just use one of the points. So I'm just going to jump straight into what we're doing. Okay, so our vector equation is equal to, what we do is we choose a point. I'm just going to choose point P. And that's going to be 3i plus 0j minus k. So that's the position vector of point P. And what we're going to do, we're going to add t, and then our direction vector, negative 2i minus 2j plus 3k. I've got my tildes, yes I do. And so we've got that. If we combine together our i's, what do we have? We have 3 minus 2t, that's for the i's that we have, plus j's. What do we have for the j's? We have 0 over here, and then negative 2t from the right-hand side of it, I guess you could say, plus k. We have negative 1 plus 3t, lots of k's over there. And so that is my vector equation. Let's keep working through it. If that's the vector equation, what's the parametrics? So therefore, we've got x is equal to 3 minus 2t, y equals negative 2t, and z is equal to -1 plus 3t. Just remind myself about what I'm trying to find again. I've sort of gotten lost with it, but I'm trying to determine the Cartesian equation. So I need to get rid of the parameter t and end up with just x, y, and z. And so I'm going to rearrange these. Okay, so rearranging, I get t is equal to, so it's going to be x minus 3 divided by -2. So that's the t of the first one. My t here will be y over -2. Sorry to squeeze it in a little bit there. I haven't left myself a lot of space. Give myself a bit more space here. And for the third one, t is equal to z plus 1 over 3. And so I've got my 3 t's, and I can equate those. And so therefore I have x minus 3 over -2. You can do some fancy stuff, like you could change that to 3 minus x over 2. That's okay. I'll just leave all of that for today. Equals y over -2 equals z plus 1 over 3. And that is the equation of my line that joins the points P and Q. It's a very similar process to if you had to find the 2D, if you had to find the two-dimensional line between 2 points. What would you do? You'd find the gradient. That's essentially your direction. And then once you get that, you substitute the point back in. It's pretty much exactly what we've done here. We've got the gradient. We found the gradient vector, which is v, and we sort of substituted in a point into my equation and then sort of just equated from there. Hope that makes sense. I'll see you in the next video.